Hi again, science students. In this video we're going to examine Newton's second law of motion. Now if you look up a definition of this law, quite often you see the definition written in different ways. The definition I have here is that the acceleration of an object is directly proportional to the magnitude of the net force in the same direction as the net force. Now this definition and others like it for Newton's second law can be a little bit confusing. In a nutshell, what this boils down to is that if you apply a force to an object, so let's say you push something forwards, then it will accelerate in that direction. So if you push an object forwards, it will accelerate forwards. And the important thing for you to remember for our course is that this all boils down to this equation, that force is equal to mass times acceleration. That's what's really important about this. Now, Newton's second law, it has an equation attached to it. So if we look at all these questions that come after, they involve some mathematics, right? And I want you, after we've done this video, or after you've watched the video, I want you to work through up until this question here, and do this one as well with the man jumping from a height of 2 meters, and we've got the picture of Michael Jordan there, who would have landed from 2 meters up in the air lots of times throughout his basketball career. But Newton's second law has an equation, so it's going to involve maths most of the time, whereas Newton's first and third laws really just involve definitions. There's no equations attached to those, so they tend to involve you having an understanding of how they work and doing more worded responses to them to demonstrate your understanding of different physical situations. So there's a few to do, and all these questions that come after pertain to the equation that force equals mass times acceleration. Right? So F equals ma. But they do come at it from different aspects or different contexts, and you do need to have an understanding of how to rearrange the equation, and a couple of them get a little tricky. I'm going to provide answers to these in the notes, but if there's stuff you don't understand about how to do any of these questions, please make sure you ask me what's going on with it. But I will do this first question in the video to get you started. So we have an object here. It has 5 newtons acting to the right and 1 newton to the left. So I'll draw a little picture of that. Just top to tail these vectors. 5 newtons to the right and 1 newton to the left. Now we're asked to find the unbalanced force. We could call this F un or F net. I'll just call it F net this time. Okay, now that's going to be equal to the result of these two forces. I'm going to say that right is positive direction. Don't have to do that, but it works best for me this time. So that means that our 5 newtons is a positive vector, and we're going to add these two vectors. So that means this 1 newton to the left is in the negative direction. So we're doing 5 take 1, which results in 4 newtons to the right as our unbalanced force. So just a note, you could also call this F un. So it looks like fun. There's a couple of different ways to show that notation. No hard and fast rule on that one. Okay. So I've got F net this time. So now we're asked, what is the acceleration of the object? Okay, so we know the force, the net force acting, and we know the mass because it's written over here. It's 1.4 kilograms. So we're trying to find A. So that means we need to rearrange Newton's second law equation. If force equals mass times acceleration, that means acceleration equals force divided by mass. So the net force is the one we use. That's 4 newtons to the right, divided by the mass of the object, 1.4 kilograms. So the acceleration will be 4 divided by 1.4 to 3 significant figures, that is 2.86. And of course that's in meters per second squared, and it will accelerate to the right. Okay, so there's a transposition of Newton's law, Newton's second law. Righto, so go ahead now, try these other questions. They can get a little tricky, but do your very best. Solutions will be provided in the notes. And like I said, if there's anything you don't understand, make sure you get in touch with me about it, and I can show you what's going on with these. In addition to that, there'll be some questions set from the booklet to try as well, and I'll put that in the description for the video. Thanks for watching.